Hello students and welcome to yet another video on foundation course for business statistics. In this video we are going to go through an example where we are given frequency distribution table along with different classes. So basically if you see these are the classes which are given to us. Uh, Looking at this class you will immediately understand that these are inclusive type of classes, right? Because port 10 and 19 would be included in this class, and there is a gap between the second class and the previous class. Okay, and these are the frequencies which we are given: 2, 12, 14, 16, and 6. Now we are expected to find out a standard deviation for this data, right? So to find out standard deviation, the first thing we should do is to make this data into tabular format, right? So the very first column which we will have would be all our classes. So there are 5 different classes, right? The classes are of inclusive type. Then the next column would be to find out what's the middle value of this class. How do you find? So you add the lower limit and the upper limit and divide it by 2. So 29 divided by 2 is nothing but 14.5. So once you get 14.5 as uh, the mid value of the first class, then you can just probably go and add 10, because uh, the class in difference between the upper limit of the second class and the lower limit of the first class is 10. So all that you have to do is go on adding 10. In fact, you see even the difference between the lower limit of the second class and the lower limit of the first class is 10. 20 minus 10 is 10, 29 minus 19 is 10. And in everywhere you will find that difference is 10. So all that you have to do is you have to add 10 to 14.5 and you'll get 24.5. 24.5 plus 10 is 34.5. Okay, so this is one way to find out. Second way can be, yes, 20 plus 29 divided by 2, 30 plus 39 divided by 2, 40 plus 49 divided by 2. So this is another way to find out the mid value. Okay, once you get mid value, what are your mid values? Actually, your mid values are your x values, right? Because we really don't know what values are actually taken by the data elements between these classes. So we will have to assume that some value is taken between these classes, and the best way to assume is to take the mid value. Okay, and frequency is given to us. So 2, 12, 14, 16, and 6 are the frequency. So if I take sigma f comes out to be 50. So there are total 50 elements in in this data set, right? And they are distributed in such a way that 2 elements are between 10 to 19, 12 elements are between 20 to 29, 14 elements are between 30 to 39, so on and so forth, right? So what do we do? Now we need to find out fx. So 2 elements are between 10 to 19, but the mid value taken by us is 14.5. So fx will be 2 into 14.5. So 29, 294, 483, 34.5 multiplied by 14 is 483. So I find fx, and my sigma fx is nothing but summation of this column, which comes out to be 1845. 1845. So 1845, which is my summation fx, divided by summation f50, gives me 36.9, and 36.9 is the mean, that is x bar, for this particular distribution. This is how I find the x bar. So once I get the x bar, I have to take x minus x bar. What is x over here? X is this particular column. So this is all mid values are x, and my x bar is 36.9, which is mean. So 14.5 minus, so 14.5, correct, minus 36.9 gives me minus 22.4. Similarly, 14.5 minus, uh, not 14.5, sorry, 24.5 minus 36.9 gives me 12 point, minus 12.4. 34.5 minus 36.9 gives me minus 2.4. This is how I will get my x minus x bar. Now, after that, I have to find the square. So square of x minus x bar is this particular column. I will square each of these values, okay, in this particular column, and that's where minus 22.4, I get 501.76. Now, since we have data in the form of frequency table, you would notice a difference between what we have calculated, or what formula we have used in our normal observations for SD and this particular formula. And this difference is, look here, here we have added f. So basically we are multiplying the frequency with x minus x bar square. So frequency is 2. So 2 multiplied by 501.76 gives me 1003. And I have to then find the sigma of f into x minus x bar. I have to find the sigma of f into f minus f bar, which is 5712. And that 5712, I divide it by 50, I get 114.24, and my standard deviation is root of 114.24, and that is 10.69. So 10.69 is my standard deviation. So there is just one very important thing that you need to note, which is a difference between calculating standard deviation for normal observations and calculating standard deviation for frequency table. Frequency has to be considered. Okay, we have seen frequency distribution tables in the initial videos, and frequency, we use these frequencies to multiply with the difference between the mid value and the arithmetic mean of that particular set of observations, or that particular set of frequency distribution. In this case, we got 36.9 as the arithmetic value. You know how to calculate arithmetic value. Arithmetic value is sigma fx. So you multiply frequency with mid value, get sigma of that, divided by total number of frequency is the arithmetic value. So this is how we should calculate 10.69. If you want, look two videos, both for standard deviation calculation for observation and standard deviation for calculations for frequency distribution, uh, closely, and see the difference, how the calculation really differs, because that will help you understand to calculate frequency distribution, calculate standard deviation for both observations, that is single observations, and frequency distributions. With this, we come to the end of video. In next video, we'll go through correlation and regression analysis. Till then, Bye.